that we just did with the fundamental theorem, remembering that, way back up here, if you look at the fundamental theorem notes, in general, there's the fundamental theorem of calculus. So if we have an integral from a to b, we integrate it, and generically, maybe that's what we have. So we're going to kind of look at some of those generic things that we're looking at. And notice that when we're integrating this particular one, that we're going in this direction on that particular one. So I got a new problem for you. Looks like this. So we got this integral, and they tell us that the integral from 1 to 4 of f of u du is equal to 5. And then they're saying, what's the value of this new integral? Well, this new integral is kind of related to that f of u, but we got to kind of do a little u substitution. So what I'm going to do is I'm going to say, okay, well, what if u is equal to x squared? Then du would equal 2x dx. That should make sense to you. There's no 2 up there, but if we make it 1/2 du, that's equal to x dx. Well, great. Now we can actually do u substitution on this. Notice that we could rewrite this integral as the integral of f of u times 1/2 du. Now, if we think about what those bounds are, again, these up here are x bounds. They're x equals. We need these bounds to be u equals because we've changed the variable of integration. Now, we normally don't write u equals and x equals on those bounds, but just know that they refer to that variable of integration. So, if we take the lower bound, -2, and we put it in for x squared, we get 4. If we take the upper bound, we'll get 1. Now, here's the key. Look what we were given. We were given this. Well, based on our work last week, what you should kind of realize is, oh, if that integral, the integral from 1 to 4, is equal to 5, then the integral from 4 to 1 of f of u du should equal -5. Because all we've done is we flipped the bounds. We flipped that direction we're integrating. So what do you end up having? The 1/2 is just a constant. This whole thing amounts to -5. So we end up with -5 over 2. And that's our answer. So that's a really good calculator question that might be asked where you can't really use a calculator. Calculator doesn't help you, but you really have to know the ideas behind integration. So let's take a look at this one. Notice on this one, the first thing you read is this right here. Well, using the work that we did last week, what that means is if g prime of x equals f of x, then the integral of g prime of x is just g of x, must equal the integral of f of x. And think about the chart that we did last week. From the work that we did last week, that process, what I just did, should make sense to you. Now, let's talk about this one that we have here. Okay, again, we don't have a rule for this 1/2, so we're going to do a u substitution on that one. We got a lot of practice with u substitution today. U equals 1/2 x. That means du is equal to 1/2 dx. That means 2 du is equal to dx. That means we can write this integral right here as the integral of f of u times 2 du. Now, our bounds. If we plug in 2, we get 1. If we plug in 6 in for x, we get 3. That's going to come into play when we get done with this. Notice what happens is if we take this integral over here that I wrote in red, if I kind of take this and I look at it, if we integrate from a to b of f of x dx, and we think about that in terms of g, that's g of b minus g of a, using that fundamental theorem. So this side work matters on a problem like this generically. What that means is on this problem that we have, the 2 comes along. That's just a constant. But what we have is we have f of 3, sorry, not f of 3, g of 3 minus g of 1. Because when we integrate, we should get back to g. We integrate f according to what we were given on this. Well, now look what we're given. Now we're given some information, right? We're given that g of 3 is equal to b. We're given that g of 1 is equal to a. So and we don't use the g of 4 and the g of 12. But what we would end up with on this is we would end up with 2 times b minus a. And I don't know, that's probably the way you'd have to put it into delta math. You could certainly put it into 2b minus 2a, and I would guess that delta math would accept either one of those. Okay, let's talk about this. I'm actually going to make a new video for you on this last portion because I want to kind of give you a new set of guidelines here for this last couple there.